Okay, so today I'm going to be going over a problem from the final exam review, number 39, part A. So this is really just going over conservative vector fields and doing line integrals in them. So the question asks, show that the line integral is independent of path and find its value. So in order for it to be independent of path, it has to be a conservative vector field. So we know, so here's the one we're trying to solve for. Now this first part is m, second part is n, or f of x, xy, little f of x of xy, little f of y of xy. So we want dm over dy to equal dn over dx in order for it to be conservative. So let's first find dm over dy. dm over dy equals 2y plus 2x. Now let's find dn over dx, and that equals 2x plus 2y. So as you can see here, they're the same because order doesn't matter in addition. They're the same. So they are equal. So we proved this right. So it is conservative. So this means that the integral is independent of path. So now we need to find the value. Do the second part of the problem. So as I showed here, the first part is little f of x of xy. Second part is little f of y of xy. So now we want to solve for little f. So let's just write this again here. So we know that f, big F of xy equals y squared plus 2xy I plus x squared plus 2xy j. So we need to find first, we know that f of xy equals the integral of f of x, little f of x of xy. Dx. So this equals integral of y squared plus 2xy dx, which equals y squared x plus x squared y plus c1y. So we also know that f of x, little f of xy equals the integral of f, little f of y of xy dy, which equals the integral of x squared plus 2xy dy, which equals x squared y plus xy squared plus c2 of x. Okay, so if you look here, you can tell that these really are the same. So we know that f of xy is, you can choose either of them to use. I'll just use the second one. X squared y plus y squared x. Oh, I moved the order, the second part. Plus k, our constant k. So now we need to plug things in. So what we want is, we know that for a constant function, we use f of final points minus little f of the initial points. So we want little f of 3, 1 minus little f of negative 1, 2. So plugging in, we get 3 squared 1 plus 1 squared 3 plus k minus negative 1 squared 2 plus 2 squared times negative 1 plus k. So the first thing you can notice is that the k's are definitely going to cancel. And this ends up being 9 plus 3 minus 2 time plus negative 4. Okay, so it's 12 minus negative 2, subtracting a negative, same thing as adding, positive. So it's going to be 14 is going to be our final answer. 14 units of work. So there you have it.